Hello everyone, welcome to my midterm video. My name is Siddharth Agrawal and I'm going to walk you through everything I have learned in this web development course till now. Let me start with the big picture. I have created this concept map that shows how all the pieces fit together. So at the very top, we have the browser. That's what the user sees. The browser uses three core technologies. That is the HTML, which is for the structure, the CSS, which is for styling, JavaScript, which is for interactivity. Now JavaScript is the place where things actually get interesting. On the front end, we use React, which is a JavaScript library that helps us build interactive user interfaces. It uses components, states, props. React uses something called JSX, which looks like HTML, but is actually JavaScript. Um, the front end can't really do everything, so we it needs to talk to a server as well. That's where the communication happens, which happens through HTTP, the protocol that defines how the request and the response works on the web. The browser sends HTTP requests using methods like get, put, post, and delete. On the server side, we have Node.js, which lets us run the JavaScript outside the browser. We have Express, which is a framework that makes it easy to set up servers and define routes. Routes are like addresses. They tell the server what to do and when to do. It receives a specific request. Express also uses a middleware. Um, it's a function that processes requests. Uh, they ca- which is usually for authentication, validation, logging. You can think of it as a final handler. Now, finally, the server needs to store the data somewhere. That's where MongoDB comes in, which is an SQL database that stores the documents, and it looks quite similar to a JSON object. We use Mongoose as an ODM, which is Object Document Mapper, to interact with our Mongo from Express servers. Mongoose lets us define schemas that enforces structure on our data. Um, so everything in this course connects through this flow through we can see over here. The front end sends the request to the back end. Uh, the back end processes them. The database stores the data, and the response comes out back to update the user on the front end. What and the user can see that. So this is kind of the overflow. Now we are going to get into the details of each of these things. So let's start with the foundation, which is HTML and CSS. So HTML stands for Hypertext Markup Language. It's the skeleton for every page, and we write HTML using specific tags like div, h1, p, form, input. Each tag defines a piece of content. HTML is not a programming language. It's a markup language. It is just used to define the structure. That's it. Whereas if we come towards CSS, which stands for Cascading Style Sheets, um, CSS is something which is used to make your HTML look beautiful. You use selectors to target elements and apply styles like color, font, spacing, layout. We learned about Flexbox and Grid for layouts, responsive designs with media queries, and box model, which is how every element has a content, padding, border, and margin. Together, HTML and CSS gives us the visual structure of a web page, but mind you, they are static. They cannot really respond to a user's action. For that, we need something which is JavaScript. If a user wants to write something, give us an input to record their responses, we need to use JavaScript for that. So so JavaScript is a programming language of web. It is what makes the web pages interactive. And so we have covered the core concepts like variables with let and constant and var, and data types like string, numbers, and booleans, and arrays, and functions, which are both regular function and arrow functions, and control flow statements, which are if else statements. Some of the other critical concepts which we have learned is about the DOM manipulation, which is the DOM stands over here for document object model. It is how a JavaScript interacts with the HTML. You can select elements from the document query selector and change the style, add event listeners, and even dynamically update the pages. We also have asynchronous JavaScript, which is huge. So JavaScript is a single-threaded language, meaning it can only do one thing at a time. But web requests can take a lot of time at times. So we use promises, which is an async await to handle operations that can take time without freezing the entire page. So, for example, we have fetch, which is the main way we can make HTTP requests from the browser, and it returns the promise, which basically helps us to continue making the page work without making it stop completely until the request comes back. So. React is a JavaScript library which helps building our user interface. It was created by Facebook and it changed completely how we think on building web apps. The core idea of React is components. Instead of writing one giant HTML file, we break the UI into small, reusable pieces. Each component in JavaScript functions like that. Uh, it returns a JSX which looks a lot like HTML, but is actually JavaScript. The other key components of React would be we can first talk about state. Uh, we use the use state hook. State is we could say state is data that can change over time. And when the state changes, React automatically re-renders the components uh, to reflect the new data. This, you could say, is React's superpower. We can change the data and the UI updates automatically. Props is short form for properties. Props is how we pass the data from a parent component to a child component, and it's just a one-way flow, which is from top to down. We have use effect, which is a hook for side effects. This is where we put the code that needs to run after the component renders, like fetching data from an API. We also have event handlings, like React handles events like on click, on change, on submit. Uh, we can change the handler functions to these events in our JSX. So let's now just move to the backend. So over here, we're going to talk about Node.js and Express. Firstly, Node.js is something which runs, which lets you run JavaScript on server outside the browser. That's huge because you're using the same language for the front end and backend. That means one language for full stack. Node.js uses non-blocking input-output. That means that whenever server is waiting for a database query or a file to load, it just doesn't sit there doing nothing. It moves to the handle other requests and come back when the result is ready. That actually makes Node.js really fast and efficient. Node.js also has some other event-driven architectures. Like instead of creating a new thread for every request like traditional servers, Node.js uses a single thread event loop that listens for an event and responds to them. This is very closely related to how a non-blocking IO works. There is also the npm. So the node package manager. The npm is how we install and manage all the packages. It's a third-party library that adds functionality to our project. Express, in fact, itself is a npm package. So is Mongoose. So we run and install Express, and it's ready to use. And coming to Express, Express is a framework which is built on top of Node.js that makes our work easier to create a server. With Express, we can define routes, which maps URL to the handler functions. For example, if we have something like an app.get with API tasks and the handler. So when someone gets when someone sends a get request to the API task, it runs the handler function. The middleware is the fundamental and express concept. The middleware is the function that sits between the request and the response. They can modify the request, check authentication, pass JSON bodies, handle errors, and much more. Anything you need to do that is before you give your final request or final response. Sorry. Also, we have the REST API, which we have learned how to design the RESTful APIs. REST is an architectural design where each URL represents a resource, and we can use HTTP methods to perform these resources, which is usually the get for read, post for create, put for update, and delete for remove. And we're going to be reading about this a lot more in further PPTs and slides as well. And also, finally, the error handling and status code, which we are again going to use, is something which an Express uses to try and catch blocks to handle errors gracefully and set them back with proper codes, like 200 for success, 400 for bad request, for 500 for server error. Good error handling means your app just doesn't crash. It tells your user what went wrong. So for storing of data, we use MongoDB, which is a NoSQL document-based database. Unlike the traditional SQL databases that store the data in the table with rows and columns format, MongoDB stores the data in a JSON-like document. If you know JavaScript objects, you basically already know what a MongoDB document should look like. It's in a key value pair. These documents are organized into a collection. You can think of a collection like a folder that groups related documents together. So you might have a user, uh, which is a collection, and a task, which is a collection. One of the MongoDB's biggest advantage, I would say, is going to be the flexible schema. Unlike SQL databases where you have a rigid table with fixed column, MongoDB doesn't force a strict structure. You can have documents in the same collection with a slightly different feel. That said, in practice, we usually still want some structure. That is where Mongoose come in. MongoDB is also a part of also auto generates a unique ID for every document we insert. So we don't have to create our IDs ourselves. MongoDB handles it with object ID, which is guaranteed to be used. Now coming to Mongoose, it is an ODM, which stands for Object Document Mapper, that we use to interact MongoDB from our Node.js code. Now Mongoose lets us define the schemas that enforce the data structure. It also lets us define models. Talking about schemas, even though MongoDB is flexible, Mongoose adds a rule on the top saying that it must have some sort of a title in a string format, a priority. This kind of gives us the best of the both worlds. I would say that's MongoDB's flexibility, but Mongoose structure, like we spoke in the previous section. It also gives us models that can provide us query methods. Once we define a model, we can get built-in methods like find, create, find by ID and update, and much more. These database operations makes it really simple and clean to work with. Also, if we are coming down to the CRUD operations, there are four basic types of data operations that we can do, which kind of sums up everything that we need, which is C for create, and then we have R for read, U for update, and then D for delete, which stands for CRUD. Every application that we're going to build is going to be revolving around these four operations. So now I am going to deep dive into one of the concepts that ties everything together. The reason to choose this was also because it ties everything. So it's about how an HTTP request gets processed from the moment you click a button in your browser all the way to the database and back. So this is the complete journey. Uh, what you can see over here on the screen. And I'm going to walk you through the six steps shown over here, and then we're going to go into the details as well. So it starts with a browser click, which like in short, the user does something on the browser that triggers a JavaScript event, which is called the fetch, to send an HTTP request. This request hits the Express server, which routes it to the handler. Then comes the validation and authentication. The server checks if you are logged in and if your data is valid. If everything passes, the data goes to the MongoDB where it gets saved, and finally React updates the response, comes back, and React re-renders the UI so that the user can see. So you can think of it as a as something, a process which is divided into three phases: the request phase where the user action triggers an HTTP request, the process phase where the server validates and authenticates it, and then the data and saves the data, and then the response phase where the data comes back and the UI updates instantly. I'm going to break it down each step into details so you can understand. But let's just say if a user is there on a website and they enter a detail or something or clicks on a button, all of this events and everything is going to take place until it reaches back to the user and the UI updates. So it all starts with the browser, as said earlier. The user is looking up at the React app. I'm just forming a situation over here to see a form. Let's just say it's a task manager. And they type something like they have to learn MongoDB. So they type learn MongoDB over here, as you can see, and then they create a task. Uh, as soon as they do this, the React fires an on-click event handler. Inside the handler, we gather the information, we gather the form data into a JavaScript object, which contains the title and priority. And then we use the fetch keyword to send this data to the server as a post request. You can see over here the method has been written as post. We can also see that we set the content type header to tell the server that we are sending a JSON, and in the body we use JSON.stringify task data, which is usually to convert the JSON object to a JSON string, because the HTTP can only can send text and not JavaScript objects. We have also mentioned over here the prevent default at the top. This stops the browser from reloading the page when the form is submitted, because we would not want that to happen. We handle it with JavaScript instead. There is also an await keyword which is very important, which pulls in the asynchronous, which we read about earlier. Um, the fetch returns a promise over here, because the network takes time to it takes the whole time. When we say we are requesting for something, it's going to go, it's going to process, it's going to reflect back onto the UI before that, so the whole thing takes time. So we would not want the browser to to freeze during this particular situation. So this is what it helps with. Then we also have over here the await JSON, the JSON parse. This passes through the JSON's response from the server, what we get, and updates the React state with the new task, as we can see over here. And we're going to come back to this. Until then, we are just going to look at when we do click and what exactly happens from here until it is rendered into the UI. It's going to be coming in step 6. We are currently in step 1. So this is the step two. Basically, this is where the actual data is sent to the network. This is kind of the raw HTTP request. In the first line, you can see over here that we have three parts. The first part is the method. We have given here as post because we are creating a new data. The second is the path, the endpoint on the server, and the third one is the protocol. Then we have the headers. These are basically the metadata about the request. The content type tells you about the server body is JSON, and the authorization sends it authorization token so that server knows who we are. Finally, we have the body. This is actually the actual data we are sending formatted in the JSON. A quick note on HTTP methods, which we have given over here, is get retrieves the data, the post creates the data, the put updates the data, and delete deletes or removes the data. We are going to be getting more into the details in the further steps on this.
The request arrives at our Express server. The Express server looks at the method and the path. In this case, it's the post API task and matches it with the route we define. But before the handler runs, the Express runs a middleware. In this case, we have an authentication middleware. It extracts the tokens from the authorization header and verifies it using the JWT token attached. to the user's ID, to the request object, and calls the next to continue. If the token is invalid, the middleware sends back a 401 unauthorized response and requests to stop here, and the handler never runs. Uh, then actually if the actual handler runs, it pulls the title, the priority, and the due date from the request body using destructuring. Sorry. Then it validates the data. Is the title empty? Is the priority one of our followed allowed values? Is the due date in the past? If any of the validation fails, we send back a 400 bad request with a specific error message. The validation is critical. You can never trust data from the client. Even if you run your own React form even if your React form has some sort of a validation, somebody could send a request directly to your API with bad data. The server side validation is your last line of defense in such a scenario. After the validation passes, we create new Mongoose documents. We initiate the task model with our validated data, which is the title, which we trim. We basically trim the title and remove the white spaces. We pass priority, the due date converted to the data object, and the user ID from our authentication middleware is complete, and the completed to set false. Then we call the await new tasks. That's safe. This is where the Mongoose talks to the MongoDB. It validates the data against the schema one more time before generating a unique ID and inserts the document into the task collection. Uh, when What gets saved looks like a MongoDB document with an object ID and all our fields and the timestamps. So we can see it over here. This is what similarly looks like. Um, Notice that in the user ID field, notice the user ID in that we can see this creates a relationship between the task collection and the user collection. Each task belongs to one user, or one user can have many tasks, but so this is a one to many relation. Once the database confirms the save, Express prepares a response. We use the 201 response, which we can see over here, because the 201 in the HTTP status code is for created, meaning a new resource was created successfully. The response includes the new task object generated with its generated ID. This is important as the client needs the ID so that it can use it as a reference in the laters for the updates and deletions. Let me also quickly cover the other status codes. I've done it in the past, but just to revise, 200 means okay. 201 means something was created, 400 means bad request, 401 means unauthorized, 404 means not found, and 500 means something is wrong. Once Back in the browser, once there's returned, the fetch promise resolves within the response. We call the response.json to pass the JSON body, and then basically the magic happens. The set tasks has multiple tasks in it, and the spread operator copies all the existing tasks, and we add the new task at the very end. This creates a new array, which is very important because React detects the state changes by checking if the reference changed. Once the state changes, the React re-renders the components. It calls the rendering function again, maps the whole thing uh, maps the whole thing into an updated task array and creates task cards for each one, including our brand new task which we added with the learn MongoDB. React then efficiently updates only the parts of the DOM that was changed. It doesn't reload the whole page. Thus, the user is able to see the task appear instantly, and the page is not reloaded. So the most amazing part is how fast this is. It gives you an estimate of how much it takes. So the click itself takes 0 milliseconds. As soon as that happens, the JavaScript event fires in about 5 milliseconds. Then we have the network, which is the biggest chunk, about 50 milliseconds, which has the request to travel to the server. Then the express takes about 30 milliseconds to route the authentication and validate it, and the MongoDB saves the data for in about 15 milliseconds. Then the response travels back to the network about in 45 milliseconds, and finally the React re-renders it in another 15 milliseconds. It takes about in a total of 160 milliseconds, which is kind of faster than the blink of an eye. The user clicks the button and sees the result almost instantly. If you see the major part is the data traveling backward and forward, and the actual server, the processing of the database is incredibly fast. So before we finish this deep dive, I want to leave you with an analogy that really helped me understand the whole thing, and I feel it could be a good way to also give you a creative understanding about the whole thing. Think of HTTP requests like ordering something on Amazon or any online platform. So the browser is the place where is the Amazon where you are browsing, and when you click on buy now, that's the click, that's the HTTP request. Express server could be treated as the Amazon system on the back end. When your order comes in, it checks whether it's your account, whether you're logged in, whether it's, your shipping address is valid, is a payment set up. The middleware can be like the Amazon's fraud detection. Before it processes your order, it asks that if it's really you. It tries to see if your credit card's details are correct or not, if you are looking to make a valid purchase or not, your expiry card, and other important authorizations. MongoDB is the warehouse. Once the order passes, it sees the item, it packs it, it shelves it, it records the item in the database that has been packed. And then we have the HTTP response, which is your shipping confirmation. Amazon sends you an email with the confirmation of your packet being shipped or whatever it be. And then at the end, React UI update could be your package arriving at your doorstep and you opening and you seeing the Amazon app. It shows delivered. The UI reflects the new state. You can see the package right in front of you in both ways, physically as well as on the web. So here's the key insight would be that every single web interaction that you have follows the exact same pipeline. Just like every Amazon order goes through the same steps, whether you are posting on Instagram, sending a message on a Slack, or submitting a form, it's always user action, service processing, database save, response back, UI update. If you update this one pattern, you can build and debug any full stack application.
So now I'm going to build this do a live coding round. I'm going to be creating a working Express server from scratch. A quick note would be I in our deep dive session we walked through the full flow with the React on the front end, the Express in the middle, and the Mongo as the database. Building all three layers live would take a lot of time. So what I'm going to do instead is just focus on the backend, that's the Express server, because that's where the core logic lives. I'll use a simple in-memory array instead of a MongoDB so that we can skip the database setup and focus so purely on how routes, validation, and HTTP status codes work. The concepts are identical. In a real application, you just swap the array for a Mongo's model. So first, I'm going to require an Express and create the application. So I'm just going to write a code for that. Um, then we are gonna uh, write the app use. So this is our first middleware. It passes the incoming JSON so we can read the request bodies. I'll also need to store it somewhere. In a real application, this would be MongoDB, but in the demo, I'm going to use a simple array and an ID counter. So uh, now first, we need to write about the get root, which gets all tasks for us. So when somebody sends a get request to this endpoint, we'll send our task array as a JSON. That's it. So Let me write the code for that. Now we're going to write the post route. So this is where things actually get interesting. When someone sends a post request to create a task, first I'm going to extract the title from the requested body using destructuring, then validate. If there is a no title, I'm going to return a 400 bad request, the status code which we saw earlier, with an error message. That return is important. Without it, the code will keep on running. So we can already see one over here. So let me just finish that. Oops. And okay, before this, then there's going to be a validation. So if the validation passes, I create a task object with an auto increment ID, the title, and done set to false. Push it into our array, that's the database where it's being saved, and then respond with the 201 created and the new task. And finally, we are going to give the app.listen. So this starts the server and tells it to listen for the incoming requests on port 3000. We can think of it like a port door number on a building, and yeah, I mean this is just gonna once this line executes, our server is live and ready to receive the get and post requests. So now we are going to start by first getting the server started on port 3000. So first let me enter the folder. Now node server.js. So now the server is running, and we are first going to send a get request, which is gonna let us know if it's working fine or not. And so we can see that the HTTP status code has been returned, which is a 200. That means it's running, and we have also received an empty array. So no task as has been created yet. I've already pre-written these commands so that we don't waste time over here. I am going to create right now a task. I'm sending a post request over here with a JSON body containing the title. As soon as we hit enter, we can see the whole thing was created. We can see the task, we can see the ID, we can see the return status code as 201, which says the task was created. The new resources was created. This is exactly the HTTP flow we walked through in the slides. I'm gonna create another task. It's gonna say an ID 2, yes, because it's been incremented automatically. Again, a 201 status code, which means it was created. Now we are going to ask to return both the task. It should give us a status code of 200. Okay, our data is persistent on the server. So let's see. Yes, we get a 200. Okay, we can see the tasks also, which we had created with both the IDs, exactly how we did a walkthrough. Let me also enter. Let me show you what happens with the bad data. I will try to send one which doesn't have any title in it. So we get a 400 bad request with it should, because it's a title which is required, which says over here as well. So our validation caught it and rejected the request. 400 over here means because the client had sent the bad data and the server protected itself. So this was the complete walkthrough for the post to create, delete, get, and the different status codes, the JSON responses. This is exactly what happens behind every web app you see. So this was my project, my walkthrough, my understanding of everything that we have done till now, and I hope I was able to explain you as well. Thank you so much for watching this, and hopefully I'll see you all next time. Peace.